Question like, what happens when you divide two powers in the same base? And like if you have a to the power of 5 divided by a to the power of 2, what happens? Most people fundamentally are confused about it. If you are not, that's great, but in my experience of about 20 years, I found that most of the students get the fundamental part wrong. So in this video today, I told you we'll have a set of 4 videos. Already we have done one, and this is the second of the 4 sets. And in this video, we'll step by step understand what is the dynamics, what goes on behind these rules and how it simplifies calculation. So stay with me, and I'm sure after the end of the videos, most of your doubts will be gone, right? So let's start with the job, but before that, please, if you like the video, hit on the subscribe button. That will inspire me, and you are with Have Fun and Learn with JP Datta. So let's move over to our main topic. Going back to the last class, I think let us review a bit. I gave you 3 rules. Number 1 was a to the power of m multiplied by a to the power of n was equal to a to the power of m plus n. Right? The second rule I gave, a to the power of m divided by a to the power of n, that can be written as a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Number 3 was a to the power of m whole thing raised to the power of n will be equal to a to the power of m multiplied by n. To that I am adding 2 more rules. Number 4, anything to the power of 0 is equal to 1, and concept of negative index. A to the power of m is equal to 1 by a to the power of minus m. Don't worry about this. Don't worry about this. We'll take up step by step in the coming videos. Today we'll discuss rule number 2. Right? See, now a to the power of m divided by a to the power of n will ultimately be written as a to the power of m minus n. Correct? Now see, this part can also be written as a to the power of m divided by a to the power of n. Correct? The concept of negative index I am bringing in, which we will discuss later on. Now see, suppose a is equal to 5 and that m is equal to 3 and n is equal to 2, right? So if you replace here, we get 5 to the power of 3 divided by 5 to the power of 2. Correct? Now see the fundamental part. So we can see we have written this as a to the power of m minus n. Correct? So here if we apply 5 to the power of 3 minus 2. So if you subtract, you get 5 to the power of 1, which is 5, right? Okay? So this part is clear. That means, say if you have a to the power of 5 divided by a to the power of 3, you land up with a to the power of 5 minus 3 is equal to a to the power of 2. Okay, so see, things become very simple. Now I can argue, sir, I can always break them up, a into a into a and so on. But the problem is when you land up with powers which are pretty big, 38, 39, 1000, right? So what happens then? You cannot expand it and then cancel. So there this particular rule of exponent helps a lot, right? Now let us solve a few problems. Number one, 5 to the power of 8 divided by 5 to the power of 3, right? Now to make things understandable or easier to understand, what we'll do it 5 to the power of 8 divided by 5 to the power of 3, right? Now if I apply this rule, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Here, what we get? 5 to the power of 8 minus 3, which is equal to 5 to the power of 5. Right? So this is a direct example of how the rule is applied. Correct? Now see, we'll make things a little bit more complicated. In these years that I've spent as a teacher, more than 20 years, what my personal observation is that most students, beg your pardon, most students make a mistake in understanding what exponent is all about. The fundamental part is missed out. They try to memorize things. It is not something to be memorized. It should be coming like, in the fingertips. So this, it will go like this, right? Now see, we will mix these two laws. We know that number one, a to the power of m multiplied by a to the power of n is equal to a to the power of m plus n, and 2, a to the power of m divided by a to the power of n. Directly I can write a to the power of m minus n. Now, the problem is 5 to the power of 5 times 2 to the power of 3 times 2 to the power of 6 divided by 5 to the power of 2 times 2 to the power of 2 times 2 to the power of 3. Okay. Now see, you have the propensity of cancelling out. Don't cancel it out. What we'll do is, we'll get the powers at one place. So 5 to the power of 5. See, this is, in these two cases, this is a division. So we can apply this rule. So minus 2. Correct. Next, multiplied by, see, we have got 2 here, 2 to the power of 3. That is in the numerator. So 2 to the power of 3. This is also there in the numerator, the same, plus 6. And see, this is in the denominator, minus 2. And this is in the denominator, minus 3. Right? So we get 5 to the power of 3 multiplied by 2 to the power of 6 plus 3, 9. Minus 2, 7, minus 3, 4. Right? Understood. Now we could have approached it in a different way. Like what? See, we can write here 5 to the power of 5 and straight away add the addition rule. 2 to the power of 3 plus 6, and also below 5 to the power of 2 multiplied by 2 to the power of 2 plus 3. Right? There you get 5 to the power of 5 multiplied by 2 to the power of 9 divided by 5 to the power of 2 multiplied by 2 to the power of 5. Correct? Now see, the same thing will happen. So it is 5 to the power of 5 minus 2 multiplied by 2 to the power of 9 minus 5, which gives you 5 to the power of 3 multiplied by 2 to the power of 4. See, we get the same result. Right? Correct. Now here is a tricky question. The question is 8 multiplied by 9 multiplied by 4 divided by 2 to the power of 3 multiplied by 3 multiplied by 2 to the power of 2. Correct? Now she will say, sir, where are the bases? There are bases. Okay, all right. But what about them? They don't have the same base. We'll convert. How? See, 8 is equal to 2 to the power of 3. Right? 9 is 3 to the power of 2. Right? 4 is 2 to the power of 2. Okay? So we'll replace 8 by 2 to the power of 3. Multiplied by, replace 9 by 3 to the power of 2. Multiplied by, replace 4 by 2 to the power of 2. See? Now we got the basis same. Divided by 2 to the power of 3 multiplied by 3 multiplied by 2 to the power of 2. Right? Now if I apply the addition rule or multiplication rule on the numerator, 2 to the power of 3 plus 2, these two, right? Multiplied by 3 to the power of 2. Got it? Divided by 3 plus 2, 2 to the power of 3 plus 2 multiplied by 3. Correct? Now, if we now further simplify, we get 2 to the power of 5 multiplied by 3 to the power of 2 divided by 2 to the power of 5 multiplied by 3. Now see, if we apply again this rule, the subtraction or division rule here, we get 2 to the power of 5 minus 5, these two, then 3 to the power of 2 minus 1. Then it lands up 2 to the power of 0 multiplied by 3 to the power of 1. Now this, as I told you, anything to the power of 0, 2 to the power of 0 is 1, or a to the power of 0 is 1. So you get 1 multiplied by 3, the answer is 3. Clear? Understood. So this is how you approach exponent when you have got no clear basis. You have to convert them. Right? So this was a mixture of application of the two rules. Okay? Now let us move on to another example. I told you, you remember this? A to the power of n multiplied by b to the power of n can be written as 8 multiplied by b to the power of n. Right? This is called distribution of power. Distribution means if you break it up, it becomes a to the power of n multiplied by b to the power of n. We have distributed the power, same power. Because it's the same power, we have distributed it. Now, depending on this, we have a problem. See, we have a problem depending on that. See, 3 to the power of 5 multiplied by 2 to the power of 5 multiplied by 2 divided by 5 to the power of 2 multiplied by 2. Right? Now see, on top, we can write it as 3 multiplied by 2 to the power of 5. Then these two we can safely cancel out, right? Because it will be 2 to the power of 0. And divided by 5 to the power of 2. So you get 6 to the power of 5 divided by 5 to the power of 2. So this will be your ultimate answer. So I think I've been able to explain what the second rule is and how it is applied. Now, in the next class, the class coming up, we'll discuss on the other two rules that I gave you, that is a to the power of m raised to the power of n is equal to a multi mn. And we'll introduce the concept of negative index, like a to the power of n is equal to 1 by a to the power of minus n. So this will be something which is, to most of the student, is pretty confusing and somewhat difficult to understand. We'll make that easy. By the way, you are with Have Fun and Learn. I am JP Datta. Please hit the subscribe button if you like it, comment and share. And as I told you in the next class what we pick up. So from here, we go on to a third of the 4 series of videos and see where you land up. But till then, enjoy yourself. Bye-bye.